Scientists worldwide had great expectations for the groundbreaking and exceptionally innovative space telescope, which came at an exorbitant cost to build. The anticipation among people was palpable as they eagerly awaited the revelations that this state-of-the-art telescope would unveil. It did not disappoint. When the initial images from the James Webb Space Telescope were made public, the entire global community gazed upon them in sheer wonder and disbelief. These images offered an unprecedented level of clarity and distance, granting us glimpses of merging galaxies millions of light-years away and planets beyond our Milky Way. Every detail within these images held the world's collective fascination, even leaving scientists perplexed with the novel and perplexing information they presented. The first dataset from the James Webb Space Telescope caused quite a stir, with some even contending that it challenged the Big Bang Theory and the concept of an ever-expanding universe. In less than a year, this remarkable telescope has furnished us with a wealth of knowledge that has fundamentally transformed our understanding of the universe. It stands to reason that a telescope capable of capturing galaxies billions of years distant and the light from the universe's birth would have no trouble providing us with exceptionally detailed images of our own solar system. Indeed, the James Webb Space Telescope has reaffirmed its superiority by delivering astounding images of the largest planet in our solar system, Jupiter. Yes, you read that correctly. NASA has released jaw-droppingly sharp new images of Jupiter that have taken us all by surprise. These images are composites of various wavelengths of light, revealing the true colors of Jupiter and so much more. As the fifth planet from the Sun and the largest in our solar system, Jupiter is a colossal gas giant, boasting a mass more than 2.5 times that of all other planets in the solar system combined. When it graces the night sky, it's the third brightest natural object, after only the Moon and Venus. Jupiter's observation dates back to prehistoric times, and it takes its name from the Roman god Jupiter, the king of the gods. Primarily composed of hydrogen with a significant presence of helium, making up 1/4 of its mass and 1/10 of its volume, experts theorize that Jupiter may harbor a rocky core beneath its gaseous exterior. Unlike terrestrial planets, Jupiter lacks a well-defined solid surface. Its continuous contraction generates more heat than it receives from the Sun, contributing to its distinctive oblate spheroid shape, which gives it a noticeable bulge around the equator. Jupiter's outer atmosphere is characterized by distinct latitudinal bands, where turbulence and storms reign along their boundaries. The most notable result of this atmospheric turmoil is the Great Red Spot, an immense storm observed since at least 1831. This colossal planet also boasts a faint planetary ring system and a robust magnetosphere, with its magnetic tail extending nearly 800 million kilometers, nearly reaching Saturn's orbit. To date, astronomers have identified 80 moons orbiting Jupiter, but there could be even more yet to be discovered. The 4 largest moons, Io, Europa, Ganymede, and Callisto, were first observed by Galileo Galilei in 1610. Io and Europa are roughly the size of Earth's moon, with Callisto nearly matching the size of Mercury and Ganymede surpassing both. Pioneer 10 made history as the first spacecraft to visit Jupiter, coming closest to the planet in December 1973. Since then, multiple robotic spacecraft missions, including Pioneer, Voyager flybys, and New Horizons, have explored Jupiter. The latest probe to rendezvous with the gas giant was Juno, which entered orbit around Jupiter in July 2016. In the foreseeable future, scientists have a strong desire to delve deeper into Jupiter's system, particularly focusing on the presumed ice-covered liquid ocean of Europa. The planet Jupiter was officially christened by the International Astronomical Union, IAU, in 1976. Since then, the IAU has been responsible for naming the newly discovered satellites of Jupiter, drawing inspiration from mythology, specifically the beloved and divine descendants of the god Jupiter. Observations of this immense planet date back to ancient times, with Babylonian astronomers of the 7th and 8th century BC having recorded their observations. In ancient China, it was referred to as the Sui star. The renowned Italian polymath Galileo Galilei's groundbreaking use of a telescope led to the discovery of Jupiter's 4 large moons, marking the first ever telescopic observation of celestial bodies other than Earth's moons. During the 1660s, Giovanni Cassini made notable advancements in our understanding of Jupiter. Using a more advanced telescope, he not only observed spots and colorful bands in Jupiter's atmosphere but also noted the planet's oblate shape and estimated its rotation period. It wasn't until 1692 that Cassini made a pivotal observation, realizing that Jupiter's atmosphere undergoes differential rotation at its equator. Jupiter boasts an impressive diameter of 142,984 kilometers. Its average density is akin to that of simple syrup, significantly lower than the 4 terrestrial planets. The composition of its upper atmosphere is nearly 90% hydrogen and 10% helium. However, due to the larger size of helium atoms compared to hydrogen, helium accounts for approximately 24% of the atmosphere's mass. Additionally, trace amounts of methane, water vapor, ammonia, and silicon-based compounds are present. Previously, both the Gemini North Telescope and the Hubble Space Telescope have provided us with remarkable images of Jupiter. Nevertheless, the recent images captured by the James Webb Space Telescope, JWST, are exceptionally sharp, detailed, and utterly mesmerizing. These images reveal Jupiter aglow with polar lights and shimmering clouds. In the JWST imagery, the northern and southern lights emit a subtle, pale fire. M.K. de Peter, a planetary astronomer, expressed surprise at the astounding quality of the imagery, as they had not expected it to be this remarkable. These images were captured by the near-infrared camera, NIRCam, on the telescope and were subsequently converted into colors visible to the human eye. The images uncover intriguing details about Jupiter, such as the Great Red Spot, an age-old storm of monumental proportions that could easily encompass the entire Earth. In the images, it appears white due to sunlight reflection, much like other high-altitude clouds. Brightness in the images corresponds to altitude, indicating that the Great Red Spot and the equatorial region both have high-altitude hazes. These observations of Jupiter were led by de Peter and Thierry Gaucher. The pictures showcase orange and yellow hues at the poles, transitioning into a mix of blues and purples towards the center. Notably, faint rings from far-off galaxies make an appearance in the background. Heidi Hamel, the Vice President for Science at the Association of Universities for Research in Astronomy, explained that several bright white spots and streaks likely represent high-altitude cloud tops of condensed convective storms. The JWST's artificial coloring highlights the planet's captivating auroras in red while rendering cloud reflections in blue. The Hubble Space Telescope, while capable of visualizing the auroras in ultraviolet light, does not match the level of detail achieved by the JWST's infrared images. Jupiter's auroras are renowned as the brightest in our solar system, ignited by charged particles interacting with the planet's potent magnetosphere, which is 20,000 times stronger than Earth's. The JWST has also turned its lens towards icy Europa, capturing its icy surface, and it has not overlooked the giant rings of the planet. It's a feat that the Hubble telescope cannot achieve. These delicate rings consist of dust particles formed when cosmic debris collides with 4 of Jupiter's moons. Luke Moore, an astronomer at Boston University, has marveled at the stunning image of Jupiter. He particularly highlighted the remarkable spatial detail captured in the infrared spectrum, crediting the JWST's large primary mirror for this achievement. The contrast in the image is truly remarkable, allowing us to perceive the faint rings with the same clarity as the immensely bright planet. A striking close-up view, captured through 3 distinct filters, reveals numerous cloud bands on Jupiter, along with its storms and auroral emissions. The smaller storms present whitish or reddish-white hues, while the cyan tones expose clouds nestled deeper within Jupiter's hemisphere, reflecting light from the primary cloud layer at a pressure of around 1 bar. This close-up image also showcases the transition from the banded structures observed in territorial and middle-altitude regions to the more intricate vortices found at higher altitudes. The reddish emissions emanating from the massive auroral ovals are attributed to ionized hydrogen atoms extending up to 1,000 kilometers above the cloud tops. Recently, an intriguing comparison was made between the earliest photograph ever taken of Jupiter and the most recent image captured by the James Webb Space Telescope, shared by astronomer Jasmine Singh. The earliest photo, taken in 1879 by Agnes Mary Clerk, an Irish astronomer, was published in her book titled A Popular History of Astronomy during the 19th century. This side-by-side comparison vividly illustrates the significant advancements in astrophotography over the past 1.5 centuries. Clerk's 19th century photo is black and white, exhibiting a grainy quality. Nevertheless, it unmistakably portrays Jupiter, characterized by its distinctive banding resulting from variations in chemical composition and temperature within the atmospheric gases. The grayish-red spot is also discernible in Clerk's photo, albeit appearing as if it's in the northern hemisphere due to the image being upside down. Moreover, the spot is notably larger in the older image. Various studies confirm that this storm was once so colossal that 3 Earths could have comfortably fit within it. Presently, it is estimated that only 1 Earth could fit inside the red spot. In contrast to Clerk's image, the James Webb Space Telescope's photograph stands as a testament to the remarkable progress achieved in the field of astronomy over the past century. The JWST represents a truly astonishing technological advancement that Clerk did not have access to during her time. However, these stunning images of Jupiter are not the only ones available. The infrared perspective, captured on January 11, 2017, by the Gemini North Telescope in Hawaii, is equally impressive. To the layperson, it might resemble a fiery banded sphere. Additionally, the Hubble telescope has turned its lens towards Jupiter, photographing it and its icy moon Europa in 2017 and 2020, respectively. Amid the distant galaxies captured in the wide-field image of the colossal planet, astute observers might have noticed 2 additional objects inadvertently making their appearance. These objects were identified as Amalthea and Adrastea, intriguingly, both moons of Jupiter. In the images, Amalthea and Adrastea may not appear distinctly moon-like, potentially leading a layperson to mistake them for stars or specks of dust. These 2 moons, however, serve as a reminder of the intriguing diversity within Jupiter's realm, comprising not only the planet itself but also its extensive ring system and an array of satellites. Amalthea's discovery dates back to 1892 when it was first spotted by Edward Emerson Barnard. Adrastea, on the other hand, was identified by the Voyager team in 1979. What sets these moons apart is their status as moons of moons. They orbit Io, a substantial and dense Galilean moon of Jupiter. Io holds a prominent place among Jupiter's satellites, being the most geologically active object in our solar system and possessing less water than its counterparts. Amalthea boasts a diameter of 250 kilometers, whereas Adrastea is approximately 20 kilometers across. In the images, Adrastea appears as a faint dot near the edge of the rings, while Amalthea is positioned almost twice as far from Jupiter's limb, accompanied by a backdrop of diffused light, adding to the visual allure. These captivating images constitute just one facet of the James Webb Space Telescope's observational capabilities. The telescope's spectroscopic prowess promises to unveil even more awe-inspiring insights into Jupiter. Astronomers recently conducted spectroscopic analyses of the Great Red Spot in near-infrared wavelengths on July 27, complemented by similar observations in the mid-infrared range. Later this year, they are planning to embark on closer spectroscopic examinations of Jupiter's auroras. What secrets might they uncover? We eagerly await your predictions and insights in the comments below.